Boom! Yes, folks, how are you going? So we're continuing in this video. We continue where we left off in the last video, where we spoke about different types of numbers. So we started off with natural numbers and whole numbers and integers and all of that. And then we kind of went down to the wire with rational and irrational numbers. Right? Because at the end of the day, all real numbers could be classified as rational or irrational numbers. So let me put that on the board. Yeah. Right? Everything we're dealing with is real, eh? It's real, as we like to say. Everything we're dealing with, real. So at this level, at the level of your typical secondary school certificate, anywhere in the world, you will primarily be concerned with real numbers, right? Real numbers, yeah? And those real numbers can be divided into your rational numbers, and your irrational numbers. Right? Irrational numbers. Alright. So we spoke at length about irrational numbers in the last video. We're still over here because we ain't finished with this yet. So let us consider certain fractions. You divide by 1, you're sure you have a rational number because, well, if, of course, you divide an integer. So in other words, all integers would fall under rational numbers because an integer could be expressed as the same integer divided by 1, or it could be expressed as some other integer divided by another integer. So we use 7, so let me stick with 7. We used 7 in the last video. So 7 can be expressed as 7 divided by 1. 7 could also be expressed as 14 divided by 2. Or any other combination of integers. 1 divided by the next, where the answer is 7. Alright? So I'm just reiterating that your whole number is also a rational number. Irrational numbers. Let me divide now and see what we get. So let us start with numbers that we could relate to easily. So let me make 10 the numerator and let me make the denominator a whole set of other things coming up the road. And let me see what happens now. Right? So I'm starting with, let me start with 1. Sometimes I just get these ideas while I'm talking, eh? So let me start with 1. Instead of 10, let me start with 1. So, alright, 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 3 is 0.333. With a dot recurring. 1 divided by 4 is 0.25. Right? 1 divided by 5 is 0.20. 1 divided by 6. We have an exception here. 1 divided by 6 is 0.1666. Remember we said generally in the last video, right? 1 divided by 7 is 0.1. Let me see, boy. 1 divided by 7 is equal to 0.142857. Alright, I just wanted to be sure. 1428571. 1 divided by 8 is 0.125. 1 divided by 9 is 1 divided by 9 is 0.111111 going down the road. 111111111 going down the road. 1 divided by 10 is 0.10, etc., etc. So remember where I started in the last video, and I said that generally, right, we have to be so careful when we're using our language to describe mathematical phenomena, right? Because unless we have our knowledge of every single instance, which sometimes we do, which sometimes we don't, and I am not professing even at this level to be aware of all the different denominators, right? Because it is something that I was considering while I'm talking. I didn't go and look it up before, and that's fine. I could do that, you could do that, but let me get the discussion going. Right? So the pattern we had said that was generally when you divide by an odd number, you have an irrational decimal. We also mentioned that if the denominator is 5, that is a notable exception. So look at right there. Right? Finite decimal, 0.20. What? We have 1 over 3, 0.333. 1 over 5, 0.20, that's rational. 1 over 7, 0.142857, I think it resumes here. 1 over 8, 0.125, 1 over 9, 0.1111 going on the road. 1 over 10, 0.10. So with the integers from 1 to 10, we see that that general pattern holds. However, when you divide by 6, what you actually end up with is an irrational number. So 6 is a notable exception to the general rule of odd numbers and even numbers. However, the reason for that is probably that the number 6 can be expressed as the product of two prime numbers where one of those numbers is odd. So I'll just go in a little deep here now. Don't hurt your head about it. If it hurts in your head, you could always watch the video again. Or you could always ask somebody else who into maths. Alright? 6 is the same thing as 2 divided by 3. Alright? 2 multiplied by 3, sorry. As opposed to all the other even numbers, well, 10 is 5 by 2. But we know that 5, we already carved out an exception for 5 for the rational number. So we don't have to worry about 10. 8 is 2 by 4. 4 is 2 by 2. 2 is 1 by 2. 6, however, is 2 by 3. So when I divide by 6, what you're actually doing, you divide it by 2, and you also divide it by 3. We'll deal with that later when we're talking about fractions. But the presence of this 3 here, seeing that division by 3 will give you an irrational number, will also contribute to the final answer here being irrational. Right? So again, all of that is just extra details that I like to add when we're talking about the maths, because I like to give the thing some life. I like to talk about it, throw the ideas to get people thinking. At some level, to stimulate a little interest in the thing, with the hope that that stimulation of interest would carry across into your work ethic when you're studying the maths and when you're trying to master certain topics. And of course, that work ethic you could expand into other areas of life as well. Right, so don't worry about that too much. Once you move out of 10 now, what you find? Well, let me divide it and see now. Excuse, 1 divided by 11 is 0.0909090909090909. 1 divided by 12 is 0.08333333. But remember 12 is 6 by 2, and remember 6 have a 3 in it. So again, it will not be correct to say that division by an even number will always give you a finite ratio. That is simply not true. Right? We will delve into it into a little more detail in another video, but I'm going all out here to make sure that we don't get our wires crossed. Generally, division by an odd number will give you an irrational number, with the exception of 5 and multiples of 5. So if you divide by 25, or you divide by 50, or you divide by 125, you will get a finite ratio. Yes? We will deal with multiples and factors in another video. So as we start to talk bring talk, as we say here in TNT. Yes? But think of all the other odd numbers. You divide by 11, you divide by 13. Let me see now. 1 divided by 13 is 0.22222. 0.07692307 going on the road. 1 divided by 14 is 0.07142, right? 14, 2 by 7. 7 is an odd number, right? 1 divided by 15 is equal to 0.0666667. So let me just correct myself. Just now I said, now and in correcting myself, we're going to expand the discussion even more. A while ago, I said that when you divide by multiples of 5, you will get an irrational number, a rational number. Let me correct that. That is not always the case. However, if you divide by a power of 5, because those are the examples that I use. So I said multiples, but the actual examples that I used would have been 25, 125, etc. 625 and all that. You divide by powers of 5, you will get a finite decimal. So 1 divided by 25 is 0.04. Talk done. 1 divided by 125 is 0.008, etc., etc. So if we divide by powers of 5, then the number will be rational. We could divide by a multiple of 5 and get an irrational number. 15 here is an excellent example of that. 1 divided by 15, we got an irrational number. So that now gives me the opportunity to highlight the difference between a multiple of 5 and a power of 5 or an exponent of 5. Right? I'll give an example in a short video clip somewhere. Right? But let's run through it here again. 5 by 2 is 10. That's a multiple of 5. 5 to the power of 2 is 25. So in other words, you could be a multiple without being a power. But of course, if you're a power, you must be a multiple. 25 is a multiple of 5. All powers of 5 are multiples of 5. But not all multiples of 5 are powers of 5. So in other words, if you multiply 5 by any number, by any integer, you get a multiple. 5 by 1 is 5, 5 by 2 is 10, 5 by 3 is 15, 5 by 4 is 20. All of those are multiples of 5. If you raise 5 to an integer power, you get powers of 5. So 5 to the power of 1 is 5. 5 squared is 25. 5 to the power of 3 is 125. 5 to the power of 4 is 625, etc., etc. We will get into some more detail about the difference between exponents and powers in another video, not this one. We can't do too much things in one space at one time. Alright? So all of this long talk is just to give you an idea of the kinds of decimals we get when we divide by certain kinds of numbers. Right? So this is just us feeling our way in the early stages. We're feeling our way through the whole concept of numbers, different types of numbers. Right? Let we consider prime numbers. Right? And we know that a prime number is a number that can only be divided by itself and 1. So again, the things are a mix up now because we just talk about multiples. It means that we had to talk about factors now. What is a factor? A factor is a number that when you divide by that number, you get an integer. So in other words, let me go back to 5. 5 is an easy number that we could relate to. Right? We said that 5 by 1 is 5. Multiples are 5. 5 by 2 is 10. 5 by 3 is 15. 5 by 4 is 20. So when you multiply, you get a multiple. You see how the English come in? And I'm sure the same thing applies in other languages as well. When you factor, you're dividing. So if you start with 20 and you divide 20 by 5, you get 4. If you divide 20 by 4, you get 5. So both 4 and 5 are what we refer to as factors of 20. Right? We will deal with it in a little more detail in a separate video. I want to take a separate video to deal with the whole question of factors and multiples because we could expand that discussion a little bit. But as we hear already, let me just take a little bit of time to go through it. 12, excellent number to demonstrate. Right? 6 by 2 is 12. 12 is a multiple of 2 and 6 because when you multiply 6 by 2, you get 12. If you divide 12 by 6, you get 2. If you divide 12 by 2, you get 6. So both 2 and 6 are what we refer to as factors of 12. So when you divide by a prime number, remember a prime number is a number that can only be divided by itself and 1. So in other words, if you're looking for factors of a prime number, you'll only get 2. The only 2 factors of a prime number are the number itself and the number 1. That is probably the best way to understand what a prime number is. Once you have factors other than the number itself and 1, then the number is not a prime number. So 1, prime number. 2, prime number. 3, prime number. So 1, 2, 3, all of those numbers are prime. 4 is not a prime number because 1 is a factor, 4 is a factor, but 2 is also a factor because 2 by 2 is 4. 5 is a prime number because 1 by 5 is 5, it has nothing else there. 6 is not a prime number. 7 is a prime number. 1 by 7 is 7, it has nothing else there. 9 is not a prime number because 3 by 3 is 9. 10, 11. 11 is a prime number. 1 by 11, it has nothing else there. There are no other numbers that it could multiply. No other integers that it could multiply to get 11. 13 is a prime number. 15 is not a prime number because 3 by 5 is 15. 17 is a prime number. 1 by 17 is 17. It has nothing else there. 19, prime number. 1 by 19 is 19. It has nothing else there. 21 is not a prime number because 7 by 3 is 21. 23, prime number because 1 by 23 is 23. It has nothing else there. 25, not prime because 5 by 5 is 25. 27, not prime. 3 by 9 is 27. 29, prime. 1 by 29 is 29. It have nothing else there. 31, prime. 1 by 31, it have nothing else there in terms of integers that it could multiply by each other to get 31. So I'm going through all of this so that we could get a feel for the numbers. And I only stop at 31. We could go for as long as we can to go. So you would notice a pattern. with the exception of the number 2. All of the prime numbers that we discussed are odd numbers. So generally, once you move past 2, if you're trying to figure out whether a number is prime or not, it will invariably be an odd number. Because if the number is even, then you could divide by 2 and get something multiplied by something. So prime numbers greater than 2 by nature are odd, but the fact that a number is odd does not automatically mean that it is a prime number, because we went through a whole set of examples between 1 and 31, 27, 25, 21, 15. Right? We have 9. We have a lot of odd numbers that are not prime because they have other factors. Right? Usually they would have other prime factors. Usually the factors of those numbers would themselves be prime. But as a separate discussion, we could deal with that in another video. Right? I've given you a feel here. We kind of spreading the feelers wide. So we just want to tickle your brain a little bit now. Stimulate some curiosity about the numbers. With the hope that that would encourage you now to dig a little deeper. Right? And you guys now have tools that, listen man, didn't exist 15, 20 years ago. So I want to take a moment here to encourage folks to use the technology. Do not use the technology for TikTok and WhatsApp and all the associated bacchanal that we just use it for normally. Use the technology. Use the technology to help you in your schoolwork. Because the same way it have bacchanal on YouTube and TikTok and all of that, it have plenty material here, out here, that will help you. Right? I putting up some stuff, but it have a whole world of material out there. Go and look for it. Go and find it. It's right there. Nice. So generally, when we divide by primes, we get irrational numbers. Let me check it out and see. 1 divided by 17 is 0.5882, going on here. 1 divided by 19 is 0.0523, 0.052631, going on here. So apart from 2 and 5, apart from the numbers 2 and 5, once you divide by a prime number, you will get an irrational number. There may be other examples of primes that you could divide by and get a rational number apart from 2 and 5. So I'm just sticking in that there as a possibility, because sometimes you're familiar with numbers up to a certain point, and then when you go outside of that, boom, you find something else. So I'll give myself some room for error there. Excuse. All right. Excuse. So let me now turn to the final part of this video. There's a particular set of numbers that I want to refer to, which would be numbers that we refer to as people would normally call it square numbers, which is not untrue, but I prefer. Let's check my mic, testing 1 2 1 2. Yes, Mike, come on. Right. You have to monitor your technology, eh? So usually we refer to these numbers as square numbers, but I want to use the more elegant phrase. My preferred terminology is perfect square. Alright? Perfect square. Of course, once you're talking about perfect squares, you're talking about a different zone of numbers now. You're talking about squares and square roots. And in talking about that, we will come all the way back to irrational numbers and rational numbers. But let me deal with squares and squares first. And let me take this opportunity to encourage people to learn your tables. Knowing your tables is one of the most foundational foundations, so to speak, in maths. We take it for granted. We have a whole set of people who sign up to do maths and they want to do the exam. But if you ask them 8 by 7, they don't know. They either don't know, or they'll take 5 minutes to figure it out, or they have to go for the calculator. 9 by 8. 6 by 7. Notice the tables are calling, eh? 6, 7, 8, and 9. Those are the ones that normally give the most trouble. 10 is no problem, 5 is no problem. 2, we more or less have a handle on that, generally speaking. 3 with a little effort, 4 with a little effort, yeah. 6 4s are 24, 7 4s are 28. 6, 7, and 8, and 9, problems. 11 is no problem. 11 8 is 88, 11 9 is 99, 11 6 is 66, blah, blah, blah. 12, yeah, we ain't so sure about the 12. So 6, 7, 8, 9, and 12 timetables. Right? I don't have my copybook here, boy. Is it here or is it not here? If I knew that I was going to discuss this, I'd make sure I have it, you know. Hold on. No. Alright. Okay, I don't have the copybook at hand here, but folks who grow up in the Caribbean, I don't know what obtains for the other parts of the world, but we in the Caribbean, we know that our little copybooks at the back, we have all the tables from 1 to 12. That is not something to play with. You must know your tables. Whatever you have to do to memorize the tables, do it, because that is one of the foundations of your maths. When you come to do bigger topics like factorization and all them kind of things, division, multiplication, indices, tables, right? Even your ability to understand negative numbers, your foundation for that is tables. So that thing that we used to do in primary school, where you start with the 2 timetables and the 3 timetables. 2 3s are 6, 6 and a 3, 3 and a 6, 2. 2 4s are 8, 2 into 8, 4, whatever it is. You know the song, right? Sometimes we know the melody, but we don't know the words. Right? This is one instance where you have to learn the lyrics. You have to learn the words, because that is your foundation. I cannot say that. I cannot overemphasize that, right? Not knowing tables is one of the biggest weaknesses that people carry into their attempt to learn maths or into their attempt to pass mathematics as an exam. Whatever you have to do, do. Legal stuff, of course, right? To learn your tables. Right? Somebody called me this week and they asked if I know any tricks to learn the tables. I don't know if it have tricks. I'm not aware of any. But even if it have tricks, at some point, you have to, when it comes to memorizing, you have to put in a certain amount of effort and time to make sure that you have it there at the snap of a finger. And then when you memorize your 1 to 12, then at some point you'll start to move into 13 and 14. Some of the smaller numbers. So you might necessarily know what 15 by 13 is. But if I tell you 15 by 3, or 15 by 2, or 14 by 2, or even 14 by 4, at some point you go start to dabble in them kind of numbers. Yeah? So again, I'm throwing it out just to stimulate your interest in the people maths. So your tables are important. And embedded in the tables, we have perfect squares. Perfect squares occur when you take one integer and you multiply it by itself. So 1 by 1 is 1, 2 by 2 is 4, 3 by 3 is 9, 4 by 4 is 16, 5 by 5 is 25, 6 by 6 is 36, 7 squares are 49, 8 squared are 64, blah, blah, blah. So your squares and your square roots are another important set of numbers that you must absolutely have down. So in the same way that your copybook has the tables from 1 to 12, then it makes perfect sense to know your squares and your squares from 1 to 12. So you know all your squares from 1 to 12. From 1 by 1 is 1, straight up to 12, 12s are 144. And then in the reverse, you have your square roots. Right? We could deal with that in a little more detail probably in another video, but I'm touching on it here. Your square root is the opposite. So if 12 squared is 144, let me take a little touch here now. Well, let's see how serious this maths is. Well, I feel it's a joke. It's no shortcut here now. If 12 squared is 144, then, let me say if then. Let me use the if then structure that most programmers use. Computer thing now. So if 12 squared is 144, then the square root of 144 is equal to 12. I tried to fit it in one line, but it didn't work. If 12 squared is 144, then the square root of 144 is 12. So once you talk in squares, you automatically talk in square roots. Opposite sides of the same coin. If 8 squared is 64, then the square root of 64 is 8. If 9 squared is 81, then the square root of 81 is 9. So in other words, all these numbers, which when we find the square root will give us an integer, these are what we refer to as perfect squares. So what would be a perfect square? Squares. 1 is a perfect square, 1 by 1. 4 is a perfect square, 2 by 2. 9 is a perfect square, 3 by 3. 16 is a perfect square, 4 by 4. 25 is a perfect square, 5 by 5. 36 is a perfect square, 6 by 6. 49 is a perfect square, 7 by 7, etc., etc., etc. So you know all your squares and square roots. Right? From 1 to 12. And then of course you start to move beyond 12, which is something that I like to encourage my students to do at all levels. Even if I have students at Form 2 or Form 3 level, we start to push 13 squared, 14 squared, 15 squared, right up to 20. So in general, and I would say this for most people, if you're doing exams up to Form 5, then you should have all your squares and square roots, not just from 1 to 12, but straight up to 20. So by the time in Form 5, you should know, for example, that 18 squared is 324, 19 squared is 361, 17 squared is 289. And in reverse, the square root of 289 is 17. So 289 is a perfect square. The square root of 324 is 18. 324 is a perfect square. The square root of 361 is 19. So 361 is also a perfect square. So there is no real visual pattern to perfect squares. You have odd perfect squares and you have even perfect squares. You just have to know it. You just have to know it. Alright? So again, I want to take this opportunity to encourage folks to learn your tables, learn your squares and your square roots, it will make a big, 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 big difference as you get deeper into the people maths. Nice? So what's all this about squares, square roots, and perfect squares? So let me tie it back now to rational and irrational numbers. Because if the square root of a perfect square is an integer, then the square root of a perfect square must be a rational number. You see where I'm going with this now, right? Now, the rational number could be an even integer or an odd integer. So, for example, the square root of 196 is 14, and I'm deliberately using numbers outside the 1 to 12. Again, just to stimulate. Okay, hold on. Right. Right. Yes, I'm deliberately using numbers beyond the 12. And then if you have, let me say, the square root of 25. The square root of 25 is 15. So you see we can have an odd rational number, odd integer, sorry, even integer, which will be an even rational number, or an odd integer, which will be an odd rational number. Both of these are the square roots. The square roots, okay, right. I have to monitor this. Hold on, just remember. Boop, 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 boop. Right, well, I get in real behind the scenes here now. No editing and thing. So your perfect square could be even, or your perfect square could be odd. So, as I said a few minutes ago, there is no visual, there's no quick visual that will tell you whether a number is a perfect square or not. You either know it or you don't know it. Alright? This is the square root of a perfect square. This is the square root of a perfect square. What happens when the number is not a perfect square? So, for example, if we decide to get ambitious and try to find the square root of 197, try it and see. 14 point. Or the square root of 200, or the square root of 250. Try it and see. Right? I'm leaving that for you as an exercise. You're following the video. You're here. If you're here, then it means that you're invested in this thing at a different level. Because most people watching these videos wouldn't get this far. So if you here, assuming of course that it didn't skip and land up here by coincidence, if you're here, it means that there's a certain level of investment, a certain level of personal discipline, and I want to encourage you to continue along that path, because once you're dealing with maths, you need that. You have to have that. Right? My videos wouldn't be exciting all the time. It wouldn't always be short and snappy. Sometimes it might be boring. Sometimes I might repeat myself. Right? One or two, you might have occasions where my face looking tired in the video, whatever. But none of those things are reasons or excuses if you're serious enough. So if you're here, then you're in the game. So even though these numbers look nice and cute, when we see 200 and we see 250, we feel a different way to when we see 197. Given. So we delve in now into the subconscious emotional reaction to numbers, which we all have even if we're not aware of it. So if you see number 100, whew, if you see number 10, if you see number 50, if you see number 40, or you see number 60, or you see number 80, certain types of numbers, there's a certain instant feeling of familiarity simply because we are accustomed dealing with multiples of 10. 10 fingers, 10 toes, 100, 200, 300, 400, 250, 50, 40. Multiples of 5. 5, 10, 15, 20. Again, 5 fingers, 5 toes. We're comfortable with certain numbers. And then you see a number like 197 and you're really feeling that number so much. Yeah? So once you're dealing with perfect squares, squares and square roots, then you have to get away from your instant emotional reaction to certain numbers. Or obvious visual pattern that you can discern that will tell you whether a number is a perfect square or not. I must we see that 4 times already, so I've seen it again. So get that out of your head. You have to memorize it. You have to absolutely memorize it. Alright? Square root of a perfect square, rational number, integer, square root of a number that is not a perfect square. That is an irrational number. So anything like this, alright? Let me say root 2, root 3, root 4 of course is 2, that's a rational number, right? Root 5, root 6, root 7, going down the road, and then of course, let me say reach root 8, and then reach root 9. Root 9 is equal to 3, rational number, right? All of these are the square roots of imperfect square. Is that a proper word? Proper term? Let me say that. Imperfect square. So you have a perfect square and you have an imperfect square. Right? In the same way that we had real numbers and imaginary numbers, let me just use the simple English now so that we could latch on to the concept. Right? So the square root of a perfect square is rational. The square root of the square root of an imperfect square is irrational. So let me clear the board, put that down, and we're gone. Yeah? It's about time enough. Video long enough. Okay? I'm making it for talk so that we start to get a feel for the people math. And notice, we talking here, we're doing no exercise, we're doing no practice. We doing that afterwards. But I really want, let me get it, let me feel it first now. Let me feel it first, and then we go do it. And then we practice it, and we go study it, and we'll get into it. But let me feel it first. Alright? So the square roots of a perfect square, the square root of a perfect square is rational number, and the opposite is also true. The square root of, now this is my term here, I don't know if anybody ever used this before. The square root of an imperfect square Papa, yo, is an irrational number. Right? And that's basically it. So, to wind up, we spend a lot of time in this video dealing with all kinds of different things. Prime numbers and all kinds of things. powers and multiples and things. But the bottom line of everything was to go deeper into the differentiation between rational numbers and irrational numbers. We started at the beginning by saying that all real numbers could be divided into rational numbers and irrational numbers. Is 0 a real number? No, 0 is not a real number. Right? So real numbers, rational or irrational. We go further now into the types of numbers that will give you irrational numbers, and we said that generally, if you divide by an odd number, you'll get an irrational number. With the exception of 5, with the exception of powers of 5, not multiples, powers. And we leave in a little wiggle room for maybe other numbers that not come into mind right now. We said also that when you divide by a prime number, with the exception of 2 and 5, you will get an irrational number. 1 divided by 2 is 0.5. Anything divided by 2 is something 0.5. Right? 1 divided by 5 is 0.2. Depending on whatever you divide them by 5, you get something 0.2, something 0.4, something 0.6, something 0.8. Rational number. Can't get more rational than that. All the other primes, if you divide by those primes, you will get an irrational number. And then we ended the discussion by going into squares and square roots. We started by highlighting the importance of your tables. And then we went into the square roots of perfect squares versus the square root of what I refer to as imperfect squares. In other words, one thing that's a perfect square, yeah, imperfect square. Simple, dimple. Alright? So the square root of a perfect square, because by its very nature, a number is a perfect square only if an integer multiplied by itself gives rise to that number. We went through a whole set of examples. So the square root of a perfect square will give you a rational number. And then we also said that the square root of what I refer to as an imperfect square will give you an irrational number. And we also went through a whole set of examples there as well. So that would wrap up this preliminary discussion dealing with numbers, different types of numbers. We could go on in a discussion, and we may actually do that, but this video and the one immediately preceding it is a very, very, very good start. If you hear any video, I trust and I hope that you hear, because you would have gone through the full extent of both videos, and I trust that if you did that, even if you don't understand everything, even if you don't remember everything, I trust that your curiosity would have been stimulated, and hopefully we will continue stimulating the curiosity, because the stimulating of the curiosity and the interest is the first part towards some level of facility with the maths. The second part is the work ethic, your consistent application and dedication and practice, which we will mention as we go along. Alright? But for now, let we feel it. Let we feel the numbers. Once we start to feel the maths, we could do a whole set of things after that. Alright? So let's take care, keep good, stay tuned. We have plenty more things coming. Boom!